Be storing in your SharePoint server? Do you know? Because that's one of the most important things to be aware of is how is SharePoint going to function as an application? Are you storing Word documents or PowerPoint files? Are you storing large graphics? Are you doing site topology rendering that is being done through a SharePoint backend? What are you storing? SharePoint now allows you to store more than ever before because it can support beyond even 2 gigabyte files. It used to be 2 gigs was the maximum potential file that you could store due to a SQL limitation. We can now go beyond that, working with file streaming and some other support tools, and we can have some huge files if necessary. Now, why would I want to put those in here? Because of the tagging and the referencing that's available in the collaboration. If those aren't needed, then SharePoint may not be where you want to store those files, but it can be, and we can start focusing our attention on that. But we better make sure that if we're parking our huge files here, and really just about any files that we put into our SharePoint environment, we're going to want to usually consider those critical and guaranteed and supported, and we want them to perform well for us, right? Users are going to complain pretty quickly if we don't give ourselves a solid, robust environment to put our files into. So our SharePoint servers themselves now support REFS, the reliable file system of Windows Server. It's like NTFS, but so it allows for permissions and allows for a lot of the same things, but it is self-healing. It actually runs the equivalent of a check disk repair on the fly. And so whenever something goes wrong at a sector level, it's able to go in and clean that up. And if it can't be repaired, to mark it and not use that spot anymore. So this is a good thing, and it's going to make sure that your SharePoint server itself and the web files it maintains are more reliable. But remember, when you upload a file to SharePoint, it does not store it directly on the web server. It's going to store it in the database backend. That's SQL. So for SQL, what are some things you want to remember? Well, you probably should be using things like RAID disks. Remember, that's where you're going to have multiple disks, and maybe you're using RAID 1, which creates a copy of that disk. So if one disk fails, that's okay. You've still got the other one. Or maybe you're using RAID 5, where you've got a disk that is storing data, another disk storing data, and then another disk storing parity to reconstruct data if data gets lost. And that parity is actually rotated per stripe of data. Essentially, as it performs writes, it rotates where the data is located and where the parity is located per stripe. Come back here again, data, data, and parity. So that means that it only has to use the parity, in this case, a third of the time. A RAID disk might be 4 or 10 or 20 disks all working together to give me more storage and to give me a degree of fault tolerance if something should go wrong. We could also be talking about support for RAID 10. RAID 10 would be an environment where I have data and then I have a copy of the data, but the data is divided in half. So the initial data gets divided and I have half the data over here, half the data over there, a copy of half the data here, and a copy of half the data there. By splitting the data, I'm able to write whatever I need to faster, right? Because I cut the workload in half. But then by duplicating that data, I'm going to get a degree of fault tolerance. Now that's spendy because it requires a lot of disks, but gives me a great degree of speed and fault tolerance. I've seen many SharePoint installations that use RAID 10. You might be thinking about using solid-state drives. Nothing wrong with solid-state drives, server-class solid-state drives. They can perform very well. This would be especially relevant, of course, for bringing up SharePoint and booting it. I'm a huge proponent of that to help get our SharePoint files up and running online as quickly as possible. But and also in the SQL environment to ensure that we can get some of our databases performing as well as possible. This is something that if you manage SQL, your TempDB, temporary database, kind of a scratchpad database, is used extensively by SharePoint, and having solid-state drives to support that may well be one of the best places to get the best bang for your buck of the purchase of those solid-state drives. And then how do you get to those drives? Are they locally located? In many cases they're not. You're going to be using a shared disk environment. So you connect to a fiber channel or an iSCSI or even SMB 3.0 file share on the network. And so you're using some sort of protocol to access storage. And that is great because that's what really supports this environment. where one server can access that data, but if it goes down, another server could jump in and access that same data and pick up where the first one left off. So those are things like database mirroring, clustering, those kinds of technologies, high availability groups in SharePoint 2012 and later, great things to be able to implement for your best performance, and they are going to require shared storage. File streaming is something that SQL can use, where it's able to take the files, the binaries that are stored inside of SharePoint, and put them to disk instead of embedding them inside of the SQL database itself. So things that are non-standard columns in the database, like a file, can be kept outside of the SQL database environment. And that's a great thing to do to support larger files. And in that case, this would be another case where we might want to call upon REFS to get more stable, reliable performance. Little side note while we're here, you might also want to think about 64K file allocation unit or file cluster sizes. When you're formatting the disks that are going to hold SQL databases, if you format them to be 64K clusters, you get the best read-write performance, because that's how SQL writes its data, is 64K at a time. So that's the good chunk for formatting your disks, is at 64K. I'm sure you're aware of the fact that when it comes to SharePoint, if we don't configure networking, we've got nothing but boat anchors, right? We've got to get this networked in order for our users to be able to connect over the network and gain access to the web servers. And the web servers and database servers and application servers are going to have to be networked together to form the idea of a farm, a cohesive set of servers that are going to operate together. So how do we do that? How do we optimize and create the best environment for the network? Well, of course, everybody's got to have preferably a static IP address, and everyone should be registered in DNS so that we can track them down. That's just kind of your basics. We should probably put them in a secure VLAN that is controlled in terms of who can access it using different protocols from outside of that network. But then as we move beyond that, there's some other things to consider as well. And that's thinking about how we're going to support load balancing. Load balancing is where we ensure that the different users that connect right here are directed not to all dogpile the same front-end server, but instead are split apart like we see here to each access their own unique web front-end connection. There are three ways that we typically are going to load balance our front-end web servers. One is to have our clients go to DNS, and DNS can have 3 different IP addresses listed for the same name. And when the first client requests that name, they'll be given essentially the list with the first address at the top. When the second client makes that same request, they're given the same list, but with the second address at the top, so that's going to be what they connect to. Third client makes a connection, we round robin, and the third address is what's given to that client. When the fourth client connects, then we'll go back to the first one again. So this ability to coordinate load balancing through DNS is somewhat effective but in a small environment, but it provides no guarantee that you'll actually get a connection, because DNS has no idea if this server is actually up and running. As for support, that actually will involve coordinating amongst the different servers and only connecting to live servers, servers that are responding to a heartbeat of validation. We can use either Microsoft software network load balancing or a hardware traffic manager, maybe using an F5 solution or something of that nature. So software network load balancing involves you actually installing the feature of Windows network load balancing on each of the servers, and then coordinating the names and IP addresses that are going to be associated with this cluster. Maybe it's www or intranet or whatever. Then there'll be a new IP address that is created and registered in DNS that represents the cluster, this new identity for gaining access to not any one server, but getting access to that bunch of servers. And then all of the servers will validate connections with each other. And if any of them are offline, then when I establish a connection, I will be directed to a network load balancing server that is online. So I'll get connected and it'll say, oh, you should talk to this guy because he's got room. Next guy connects, oh, you should talk to me because I've got room now. Oh, no matter what, we definitely shouldn't get connected to this guy because he's not running currently, so we'll get directed to one that is running. Right? That's the idea of network load balancing. And everything that we just described is exactly what would happen with a hardware traffic manager, except it's being managed through an interception point. It could be a router or another specifically dedicated device that is jumping in, and we are directed to connect to that device when we contact DNS. DNS is pointing me here, and then that device is able to spread that workload amongst the different servers that host the service that that device has registered with it. And so that configuration, of course, is proprietary to the device, but it is able to redirect amongst those services. So that's kind of our three options for load balancing. Okay, DNS round robin, limited scalability and support, doesn't even know if it's online. Microsoft software and network load balancing, it's software based, it slows down the server because it's another service running on your web front ends, and but it does provide connections to live servers. Hardware traffic manager, all the benefits of software NOB, but now we've delegated it to a central device. We can put our certificates there on that central device. It definitely improves performance. It's easier to extend it out over time, but of course you had to pay for that device and the extensibility that that device provides. Another thing to be aware of is something called SharePoint Request Management Service. And this request management service is often something we will want to run on our distributed cache servers, will also be our request management servers. And the idea here is we're going to have one or more servers that are hosting that centralized cache and request management service. And when I contact DNS for my DNS name, I'm going to be directed to one of those servers. Okay, a request management server. The request management server is aware of all of the servers that host a particular website, a particular web application, and it can direct the client to come into contact with the appropriate server. The benefit there is we can actually have weighted load balancing. We can validate at not a server level, but a service level that the request is available. We could actually use this to block requests. If we have certain clients we don't want to connect in at all, or certain types of requests that are not valid, then we can block them exclusively. And although all of these servers potentially host all of the web applications, so if I build, let's say, an intranet and an extranet on my farm, through request management, I could say, use these two servers with this one being preferred and this one being secondary for the intranet. And then let's go ahead and use these two servers for my extranet, with this one being preferred and this one also being a failover situation. So a lot of different ways that you could configure it, and it's within SharePoint rather than being based upon an external service. The typical scenario that Microsoft recommends is that you actually have this configured with your hardware load balancer in the front, and then you connect to the request management service. And again, the hardware load balancer would direct you to one or more request management servers, and then the request management servers would be responsible for getting you in touch with a healthy web front end. And it seems like you're putting in more work, more processing, but this actually ends up being the best load balancing, the most streamlined access, the best caching configuration that you can actually get for your SharePoint environment. So this is what you should be looking for down the road and planning for as you think about your best optimization to scale to support hundreds and thousands of clients connecting to SharePoint simultaneously. Some of you are probably wondering now, okay, does my physical server, or does what my virtual server has assigned to it, does it meet the minimum requirements to be able to install SharePoint, or am I going to have to give it more in order for it to function? Well, here's what you're going to need before you step up to the SharePoint 26 installation plate. You need to know that you have Windows Server 2012 R2 Standard or Data Center Edition. Those are the supported editions. So we're not throwing this on a Windows desktop, we're throwing this on a server. We need to have memory, and the memory can have some differences depending on what you're going to be putting on this server. Remember, it might be a distributed cache or a web server, an application server, but in general, 12 to 24 gigs of memory is the recommended minimum for configuration. In practical aspects, I usually see more like 32 to 64 plus gigs of memory being assigned out. But again, in terms of minimums, 12 to 24 is what you're looking at. You definitely want to have a 4-core 64-bit processor on each of these servers in order to get the installation done. Again, that's something to remember when we are creating virtual machines, whether you're working with ESXi in VMware or Hyper-V in Microsoft, the default is typically to assign a single core, and you really want multiprocessing in order to get the best performance out of SharePoint. So give it 4 cores to work with. 80 gigs of operating system disk space and 100 gig data drive. And remember, this is not our SQL server. This is talking about support for the various files that are going to be installed on an application or a web front-end server, distributed cache server, search server, so on and so forth. Finally, make sure that you have a server that has all of this installed. It's going to have Windows Server 2012, R2 at least, and then we would want to install either SQL Server 2014 SP1 or SQL 2016 in order to support SharePoint. So SharePoint 2016 cannot be installed on SQL 2012. It needs to be 2014 Service Pack 1 or later. Additionally, there are some specific components that need to be installed into that operating system. So I talked about the hardware. What about the software before I install the SharePoint software? Well, I need to have IIS installed. All right, because that's my web server service. That's what's going to allow Windows to start listening at port 80 or 443 or whatever we run at and have worker application pools associated with the web engine. We also need the application server rule, which is tied into .NET management. Specifically, I need the .NET Framework version 4.6. Now, this is good news. If you installed previous versions of SharePoint, you no longer need to be concerned about the legacy .NET Framework being installed. We just need the latest framework in place. That also means that security patches and things like that will not be a problem. You can have a fully up-to-date server, and it's ready for SharePoint 2016. You'll need to have the SQL 2012 native client. Again, that's the native client that will coordinate the behavior correctly. Windows Communication Foundation data services needs to be in place. Information protection and control clients, sync framework, app fabric. These are different things that coordinate communication and register over the network. Update package for app fabric, ODBC driver for SQL Server, and the redistributable packages for Visual Studio 2012 and 2015. All to enable proper workflow management and other things that are running inside of SharePoint 2016. Now here's the good news. If you don't have all of these things installed, or if you're not sure you have them installed, the SharePoint installation media has a tool called the Products Preparation Tool. And anything that's missing from this list, it will put in for you. How cool is that? So you need to plan ahead for this, and the preparation tool will go online and grab it for you. But if you are trying to do the install and you don't have internet access, you can create your own shared folder, and the preparation tool can be manually told through scripting to point to that installation directory where you've copied from the internet these various tools and gotten them in place. Again, while we're thinking about deploying SharePoint and getting the install correct, I wanted to take a moment and just talk briefly about the idea of add-ins or apps, as they used to be called. What we're referencing is the idea of having the ability to support new code, new ways of doing things, new ways to display things, new ways to connect to various different services. When we have an app or an add-in installed, it can be hosted locally or in the cloud. So when I'm on a page and that page involves an app, and that app involves, let's say, telling you the weather from an external service, typically that means that that particular app is going to be hosted by an external provider. You essentially have a pointer to where that add-in is actually located in terms of its code content that'll be deployed to the browser. And so we are going to be using CSAM, REST, and Open Authentication to get there. We can also have SharePoint hosted apps, and that's going to be for things that are typically a little closer to home. Let's take a look at that. So SharePoint hosted, again, we're dealing with things like JavaScript, custom pages. There's no server-side code. This would be a way to change how you display lists, libraries, pre-built workflows that work with your content. You have a way that you want to display things that SharePoint doesn't support out of the box. You can create your own add-in and then install it, and it can be hosted locally. This is something that's going to really be another service to be aware of that you're going to want to have running on an application server, and it's going to be one that you want to typically perform pretty well, because this is going to be a part of what is essentially embedded into a web front end, is an add-in that displays this content for you live. So you're going to have a specific application server performing that role and able to give you the ability to access those add-ins.